take a look at your graphing quadratic worksheet, which is one that I apparently don't have. You have 3 tables and 3 graphs. Use each of those tables to graph all 3 functions. Some of them are quadratic and some of them aren't. So I'll pause the video for a second while you work on that. So this first one looks like a straight line. Should we connect the dots? We don't know, right? We don't have any idea where these numbers came from. So if you connected them, that's fine. If you didn't connect them, that's fine. We don't have a context to compare it to. Maybe you should, maybe you shouldn't. We don't know. Okay? It's obvious from the picture that it's linear. Can you look at the table and also determine that it's linear? How? If it goes up by the same number every time. So, and when you do the differences, you have to do them in the correct order in order to get the sign right. So, the difference is 1, obviously. Is it a positive 1 or is it a negative 1? Well, how do you go from -3 to -2? You add 1. And if you forget that, it's really easy. Take this number, -2, and subtract the number above it, -3. So on my calculator, -2 minus -3 is going to give me a +1. So I have a first difference of 1. What is my next first difference? 1 plus 1 plus 1, and that continues all the way down. Okay? If my first differences are positive, how is that going to affect the shape of the line? It's going to go up. If my first differences are positive, then the line is positive. It's going up. Okay? So we take a look at the second one. Is it linear? No. Is it exponential? How do we know? Right. The shape of it itself tells us it's not exponential, because exponential would look something like that. Okay? Can we determine from the chart that it's not exponential? How would you do that? Oh, okay, if you looked at it, if you look through the numbers, exponential can only go in one direction. It can never change directions. So Cameron looks through here, positive, 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 down to 0, and then back up. That can't happen in exponential. Okay? How else could you tell it's not exponential? Oh, good, it hit 0, 0. Exponential cannot hit the x-axis. What did you say? Somebody back. Right, can an exponential have the same y value twice? No, it can't. Well, let's test the common ratio. So I'm going to take 16 and I'm going to divide it by 25. So 16 divided by 25, that is my ratio, 0.64. If I do the next two, what should I expect if it's exponential? 0.64 again. And again, you always do this year divided by last year, or next year divided by this year. So now I move on to 9 divided by 16, and they're not the same. So this is not exponential. Okay? How do we test to see if it's quadratic? We need to look at the second differences, which means we need to calculate the first differences. How do you get from 25 to 16? Minus 9. And if you're not very good with that in your head, you can always just do 16 minus 25. And it gives, oh, I did it. No, there we go. 16 minus 25 is -9. So -9. How do we get from 16 to -9? Or from 16 to 9? minus 7, minus 5, minus 3, that's 3, minus 1, then what happens? Plus 1, plus 3, plus 5, plus 7, and plus 9. Obviously not linear. Do you see a pattern in the first differences? Well, we got to be careful. How do you get from negative 9 to negative 7? Add 2. So if we did negative 7 and we subtracted negative 9, that's going to give me a positive 2. So plus 2. Does that pattern hold? Yes. Even when the graph switches directions? How do you get from negative 1 to positive 1? Add 2. Okay? Well, when we did the linear version, when the first differences were positive, how did that affect the graph? It went up. Now here we have second differences that are positive. How does that affect the graph? It curves up. It's a U shape that curves up. So whenever these second differences are positive, the U is going to point up. Okay? I think I actually have the next one on here somewhere. Nope. Can I steal your paper again? Thanks. So if you look at the third graph, obviously not linear, obviously not exponential. Let's test to see if it's quadratic. So we need to calculate first differences. How do you get from negative 27 to negative 16? You add 11. So plus 11. How do you get from negative 16 to negative 7? Add 9, add 7, add 5, add 3, add 1. Then what happens? Minus 1, minus 3, minus 5, and minus 7, and so on. Do you see a pattern in the first differences? Yes, what is it? Subtract 2. So if I write out these second differences, I have minus 2, minus 2, minus 2, and so on. The second differences are negative. What effect does that have on the graph? It opens down. Okay? If I knew that equation, if it opens down, what do I know about the x squared portion of that equation? It's negative, just like the pig story. In the lawn mowing story, we had x squared plus 2. That x squared is positive, which makes the u open up. In the pig story, the u was opening down, and we used negative x squared. So if we go back here, we can assume that the rest of the graph would look like that. And on the pig story, we could assume that the rest of the graph would look like that. Okay? All right, that one's done. Go to the one that says Intro to Parabolas. You won't need to.